Now we have already seen the VSEPR theory and we have seen the Lewis concept. Now VSEPR theory has got limitations. What is that? VSEPR theory could say only the shape of the simple molecules, not about the odd electron pairs, not about the complex molecules, and it could not. It's what you can say. It's properties. It could not say all the properties. It is so what theoretical. We can say that some of the properties which was put forward by VSEPR theory was more or less it was theoretical. It is theoretical in nature. Theoretically, we can know about explain the formation of the molecule. We can explain the properties of the molecule theoretically. So it was not convincing, so to say. Not for all the molecules, I am saying. Repeatedly, I am saying it's not for all the molecules. Some of the molecules. It's not so convincing, that particular one, about the that is the properties, about the nature, about the reactivity, about the reactions. It was not so convincing. Alright. So then next it came your valence bond theory. Due to this reason the valence bond theory came into being, because first of all, as I said, we were not able to explain the what you can shape of all the molecules. Very simple molecules we could explain by VSEPR theory. We could not explain the properties or the characteristics of all the molecules, because theoretical explanation, it was completely a theoretical explanation. It did not have any practicability, means it was not guided by any practical verification, so to say. For that reason, I don't say it is rejected, of course, but it is not accepted for all the compounds. So hence came the valence bond theory. The valence bond theory was, first of all, it was given by Hitler and London. Hitler and London gave this particular theory. Hitler and London. What they said, a very simple sentence it is, that the presence of one or more unpaired electrons in the valence shell of an atom is the cause of chemical bonding. The presence of one or more electrons in the valence shell of an atom. Alright, means I will explain with help an example. Like let us say hydrogen, atomic number 1. So it is 1s1. So here we can say one unpaired electron is there. You can say that. Alright. Now we are having, let us say, chlorine, atomic number 17. So 1s2, 2s2, 2p6, 3s2, 3p5. So we are always interested with the outermost subshell, because innermost shell or subshell is fully filled, innermost. So 3p5, 1, 2, 3, 4, 5. You should fill it up in this manner always. Make it a practice that you should fill it up in this way. First, unpaired. Alright, you will fill it up. Then after that, the pairing is going to take place if at all any electron is left. So you can see here, one unpaired electron is there. One unpaired electron. And here also one paired electron is there. Now this is the cause of chemical bonding between hydrogen and chlorine. That is what it was said by Hitler and London. The presence of one or more unpaired electrons in the valence shell of an atom is the cause of chemical bonding. The presence of one or more. Now here one unpaired electrons, here one. Suppose if you take oxygen, you will be getting two unpaired electrons, you will be seeing it. Alright. So that is the presence of one or more unpaired electrons is the cause of chemical bonding. It is a very simple sentence given by Hitler and London. But it was the postulates, I mean to say, it was not given by Hitler and London. The postulates of this particular valence bond theory, that is VBT, we can say that the postulates was not given by him, it was given by Pauling and Slater. Pauling and Slater, they gave the postulates. Alright, they gave us the postulates, means they took it forward, rather I should say, because they gave us just one sentence, but they took it forward. They, what you can say, studied the Hitler and London's valence bond theory, and that the same sentence they made different points and they explain the theory in terms of points. That is known as the postulates. Now, before moving to the postulates, we'll understand a little bit about the valence bond theory. Then we'll understand the postulates. It will be easy for us. Fine. So, now next is what I said. The presence of one or more unpaired electrons is the cause of chemical bonding. That was said by Hitler and London. Alright. Now, always remember that whenever an atom approaches another atom, there are four forces which always acts upon it. Listen carefully. Whenever any atom approaches any other atom, now both the atoms should have unpaired electrons, mind it. You will not say here, suppose neon atom is approaching hydrogen atom. Nothing will happen. What is going to happen? Nothing. Because neon, the outermost shell is fully filled. Now, where the bond formation is capable of taking place, we will talk about that particular atom only here. That means we need to talk something rational. We can say that. Okay, fine. So what I said, that is basically two forces are acting upon it. One is nothing but the force of repulsion between the two atoms, and another is the force of attraction between the two atoms. But there are some other forces also. Two more forces are also being there, which I am going to talk about you. Got it? Otherwise, when one atom approaches another atom, suppose these two atoms are there, they are approaching. So they have to overcome the repulsive forces first. Then they will, what you can say, they will undergo bond formation, and hence they will have the attractive forces. So basically we are having attractive forces and repulsive forces. Suppose one atom is A, another atom is B. So there will be repulsive forces between them, because outermost shell both contains electrons in it. They have to overcome the repulsive forces first. Then after that, they will undergo bond formation, and hence they will have attractive forces. Again and again I am repeating this, because these are the two major forces. Apart from that, there is a force of attraction. You may note it down also. There is a force of attraction between the nucleus of atom A and the electrons of atom B. Nucleus of atom A and the electrons of atom B. Third, over. Now fourth, there is a force of attraction between nucleus of what you can say, that is atom B and the electrons of atom A. Again, there is a force of attraction between the nucleus of B and electrons of A. First I said nucleus of A and electrons of B. Now I am saying nucleus of B and electrons of A. And other two forces are, that is the force of attraction between A and B and the force of repulsion between A and B. We can select. Clear? Or we can say the force of repulsion between two electrons and force of attraction is between the electrons and the nucleus. We can say that. Clear? That is, we can say that. So now in this way, these are the four basic forces. Again I repeat: force of attraction, force of repulsion between the two atoms, force of what you can say attraction, nucleus of atom A and electrons of atom B, then force of attraction between nucleus of atom B and electrons of atom A. Alright, this you need to understand it. Now we will understand this thing graphically, alright, which is very, very important. Look here and understand it. Look here. So here I am taking potential energy in the y-axis, and in the x-axis I am taking internuclear distance. Now let us say the two hydrogen atoms I will be taking it. It can be any two atoms, but I am taking the example of hydrogen atom and I am going to explain you. It will be better. Let us take an example. So what will happen is that two hydrogen atoms are at infinite, alright, distance from each other. They are infinite. Now they are coming closer. Now when they are coming closer, let us say the two hydrogen atoms is here somewhere. Alright, it is here somewhere. The hydrogen H plus H, I will say that it is here somewhere. Now when they will come closer, what will happen is that they are coming closer. So what is happening? That is, repulsive forces is decreasing and attractive forces is increasing. Alright, listen carefully. Repulsive forces is decreasing and attractive forces is increasing. So when the attractive forces is taking place, energy is released. Energy is being released. Alright, when the attractive forces is taking place, that is, energy is released. So initially what you will find is that is when the atoms are approaching in this way. So you will find here the repulsive forces is there. Now when the repulsive forces will decrease, attractive forces is going to increase. Energy is what happened? You can see the energy is decreasing. Initially the energy is here. After that energy remains constant initially. Then after that, when the attractive forces starts increasing, energy is decreasing. Alright, energy decreases. Do you think it is going to decrease infinitely? No, it is going to decrease to a certain extent. Alright, let us say it decreases here. Let us say it decreases here. Then after that, again it increases. Again it increases. Now, in case of hydrogen atom, what is this value? Alright, what is this distance? Alright, in case of hydrogen atom, from where we have started with what you can say, arbitrarily we take the energy as 0. You know that in atomic structure we have taken. Arbitrarily, when the atoms are at infinite distance, arbitrarily the energy is taken to be as 0. We are taking the energy to be as 0. We can say that. Now, here when the energy is released, initially the energy remains same because it has to overcome the repulsive forces. Then after that, when the attractive forces is taking place, because the atoms are coming closer, you can see internuclear distance is decreasing. Internuclear distance is decreasing. You can see it here, decreasing. Energy is also decreasing. Why energy is decreasing? What I said, when the atoms are coming closer, it will overcome the repulsive forces and attractive forces is going to take place. When the attractive forces is going to take place, energy is being released. Alright, now, what is this? The lowest energy it is going to attain minus 433 kilojoules per mole, we can say that. Minus 433 kilojoules per mole. Energy is in kilojoules per mole. Potential energy, I am writing it. So, minus 433 we are having it in the graph, we can say that. Alright. Now, what is this distance? This particular distance is known as nothing but the bond length. Alright, this particular distance is known as the bond length. Let me represent it by DO, let us say. Here DO represents what? The internuclear distance between the two hydrogen atoms. I have taken hydrogen atoms, internuclear distance between the two. Got it? So, what happens is that beyond this, now this is internuclear distance. This is the distance between the two nucleus, which is represented as DO. And in case of hydrogen, this is your 74 picometer. In case of hydrogen, this distance is your 74 picometer. We can say that, which is otherwise known as bond length. Now, if you want to decrease further, can you decrease further? No. Why? Because when the two atoms they are coming closer, energy is released. Then after that, it is at the minimum, but you can say energy. Alright? And the bond length is maximum. But still, if you want to bring closer, what will happen? Again, it will start repelling. Why it will repel? Because now the nucleus of both the atoms, listen carefully, now the nucleus of both the atoms, after attaining this energy, still you want to bring closer. So it is not possible. Why? The nucleus of both the atoms, both the hydrogen atoms, now they will repel one another. Due to repulsion, again energy is increasing. Alright, so this is the lowest energy where the atom will be stable. Alright, where the atoms will be stable. This is the lowest energy because when the repulsion is there, instability is there. When attraction is there, stability is there. So here what you will find is that the attractive forces and the repulsive forces that balance each other. Initially there was repulsive forces. Now after that repulsive forces decreases, attractive forces increases. Here the attractive and the repulsive forces balance each other. And that particular, what you can say, the bond length is known as the, nothing but known as the DO, which is known as the bond length of a given molecule, we can say that. Now beyond that, if you want to decrease the bond length, it's not possible. Why? Because again the repulsive force is going to increase. Why? Because the nucleus of the two atoms will repel one another. So hence energy is again, it is increased for that particular purpose. Now this particular energy, this one, this is known as what? It is called as bond energy, which is known as, or bond enthalpy. Let me write bond energy. You do not know about enthalpy, it is called as a bond energy. This is the. Alright, so higher is the energy released, more stable is the bond. Remember it. Higher is the energy released, more stable is the bond. Because for dissociating that bond, again the same amount of energy is required, isn't it? So here how much amount of energy is released? Same amount of energy will be required to break the bond again. For that purpose, higher is the energy released, more stable is the bond. Alright, and to again break that particular bond, which is called as the bond dissociation energy, will also be higher. So if the energy released is higher, then energy absorbed to break the bond is also higher. We can say that. Clear? So in this way, the formation of a molecule takes place. Here I have taken hydrogen molecule, you can take any other atoms. Here I have taken the formation of hydrogen molecule. Two hydrogen atoms I have taken. You can take any other atom and you can explain the formation of this. The basic concept will be this much. Then you will be having the minimum, that is the energy which the bond with the two atoms is going to attain is known as the bond dissociation energy. Here in case of hydrogen it is this much. This is bond energy, this much it is bond enthalpy. And this is your bond length. In case of hydrogen it is your 74 picometer. Alright, initially we take arbitrarily when the atom is at infinite distance from the nucleus. So that is at infinity both the atoms, then the energy is 0. Then after that when they come closer, the energy decreases. Got it? The energy is decreasing, so to say. Clear now? So this is your bond length, this much, and this is your bond, we can say energy, we can say that the bond dissociation energy. This is how the formation of, that is the bond takes place, or the formation of molecule takes place according to the valence bond theory, I should say that. Now I'll explain this one in another manner. I'm going to explain it. I'm going to explain it in another manner. Alright, I hope you understood this particular graph. So now in another manner is, that is the forces which I said you, that forces I am going to explain. Now always remember that what I said, when the attractive forces and the repulsive forces they balance each other, just now I said, that means the molecule is said to be stable. When the repulsive forces is more than the attractive forces, it is unstable. Got it? Clear? Or at the most, attractive forces can also be more than the repulsive forces. Then also it is stable. Clear? Either attractive force is equal to repulsive forces or attractive forces can be greater than repulsive forces. Then the molecule will be stable. But if repulsive forces will be more than the attractive forces, the molecule will be unstable. Definitely. If repulsive forces is more, it is unstable. They are going to repel one another. They are going to move far apart from one another. But when they come closer, then the attractive forces is taking place. The stability takes place. Alright? Fine. So with this concept, I am going to explain the formation of hydrogen molecule. Now, you know, hydrogen has got one electron and one proton in its nucleus. What you can say, in its atom. So this is one hydrogen atom and this is another hydrogen atom, which contains one proton in its nucleus. This another atom contains one proton in its nucleus. And it has got one electron in its shell. This hydrogen atom got one proton, one electron. This hydrogen atom got one proton and one electron. So what are the forces it is possible here? Now you can see we can have this forces. This is your what? Repulsive forces. I am writing it as R. Again, this is what? This is your what you can say repulsive forces. I am writing again it is as R. Here, let me write it here. It is better. So it is R. Clear? So we are having repulsive forces between two electrons and repulsive forces between the two nucleus. Now, you see here, we are having an attractive forces between this atom, nucleus and the electron, and here also we are having an attractive force between this atom and that of the electron. We are having it. At the same time, as it is an electron nucleus and its electron cloud, we can also have, now this one let me put a dotted line, it will be better so as to differentiate between the attractive and the repulsive forces, so to say. Let it be the dotted line. So here also we are having some amount of attractive forces. Here also we are having it. Some amount of attractive forces between this proton and electron and this proton and electron. Alright. So here how many attractive forces we are having it? We are having 4 attractive forces. How many repulsive forces we are having it? We are having 2 repulsive forces. Here attractive forces is more than the repulsive forces. The energy is released and hence the formation of molecule takes place. Hence the formation of molecule takes place and results in the formation of molecule. You can see a molecule is being formed. We can say that. Clear? In this way the molecule formation takes place. Got it? Clear? So not only there should be presence of unpaired electrons, but also the energy should be lowest. Because if energy is highest, even if the molecule is formed, it will not be stable. It will be unstable in nature. But here hydrogen molecule is being stable, we can say, because this is one hydrogen atom and this is one hydrogen atom, and it gives rise to an hydrogen molecule which is known as H2 molecule. Here also the question may come that why H3 and H4 is not possible. The answer is very simple. In one hydrogen atom only one unpaired electron is there. In another hydrogen atom another unpaired electrons is there. So they combine to form H2. There is no other unpaired electron present which will combine with another unpaired electron of hydrogen to form H3. Understood? Let me repeat once again. In one hydrogen atom there is one unpaired electron. In another hydrogen atom there is another unpaired electron. So they will come closer to each other. They will overlap with one another to form H2. H2. Only one unpaired electron is there. Is there any another unpaired electron present which will combine with another unpaired electron of hydrogen? No. So hence as there is no unpaired electron present, then there is no question of formation of H3 or H4 molecules. For that purpose, H3, H4 molecule does not take place. Only H2 molecules takes place. Okay, thank you.